Hello, sir. Yes, sir. Sir, both combined, sir. Actually, one month. Second one, they told that they will come in the after 5:30. Hope so. Yes, sir. Yeah. Yes, sir. Yes. Done, sir. Done, sir. Thanks. So I need to start this chapter, right? Online students, someone respond. Am I audible properly or not?
Yes, sir.
Yes.
Right. So in previous class, you are done with crystal effects, right? Electrical and magnetic properties of crystals, correct? No one is writing it. Whether it is done or not, perfectly done now. So I will start this chapter then. If there is anything pending, theory part only, sir will complete it, right? So let me start with this chapter then. Yes, sir. Yes, sir. Come in, sir. Now see, sir. So in this chapter, we majorly study about speed of a reaction, right? We call that speed of a reaction as rate of a reaction. Under this side heading, we will see about two concepts. One is average rate, and the second one is instantaneous rate. Average rate, instantaneous rate. This is one part. After this, we need to study about kinetics of a reaction. To study kinetics of reaction, we need to know some parameters, right? For that, first we will see about law of mass action. Right? Here, we will see what is molecularity, what is order of a reaction, right? Molecularity, order of a reaction, and we will study about rate constant. Then we will see regarding different ways of calculating a rate constant. Among them, we preferably see integration method of determining rate constant. Integration method of determining a rate constant. After that, we will see first order reactions, second order, third order, zeroth order reactions, right? And respect to graphical representation. And there we will see reaction mechanisms also. Right? Versus order. So by seeing reaction mechanism, we will calculate order of a reaction. Then this is the third part. First part we will see about rate of a reaction. Second, we will discuss about law of mass action. Third part, we will discuss about integration method of determining rate constant. And fourth part in this chapter, experimental methods of determining order of a reaction. Particularly in case of first order reactions, in terms of volume, in terms of pressure, in terms of optical rotation, and so on. Right? Then we will study regarding collision theory. After this, we will go for hello. Hello. Yes, sir. Yes, sir. Yes, sir. Okay. Okay. Not yet started now. It is Okay. And further, we have given backup separately at the Kalavas itself. But mostly we are starting in the next week of weekday, we are going to start. So then we can ask him to join later. But these days at Madurai, one batch. We could see. So after this, we will go with collision theory. Please. Then we will see some graphical representation, Arrhenius equation, and so on. Then we will go for complex reactions. Then we will study with complex reactions. Under complex reactions, we will see parallel reactions, sequential reactions, or we call them as consecutive reactions, opposing reactions, right? So these are three complex reactions we will see. And then we will go for nuclear chemistry. Under nuclear chemistry, first we will study regarding different ways of disintegration. Means both natural, artificial. Then we will study regarding properties of particles which get disintegrated. Means properties of alpha, beta, gamma. And then we will study regarding stability of nucleus. There we will see about binding energy per nucleon, N by P ratio. Then we will see about kinetics of nuclear reactions. Then applications of radioactivity. Right? So these are the topics of this chapter. Seems to be a little big one, right? In fact, it is combination of two chapters, chemical kinetics and nuclear chemistry, two different chapters, right? In JEE mains, nuclear chemistry is not there, but for advanced, it is there, right? Now, same thing you will study in physics also, but under the name nuclear physics. In nuclear physics, you will study from these complex reactions to applications of radioactivity. All these things you will study in nuclear physics again. A little different. Almost everything is same, right? So first, let me start with the first part. What is it? Rate of a reaction, or we call it as speed of a reaction. You are not coming regularly, right? From many days you are absent. Huh? You are really attending. What's your name? Roslyn. Okay. Now coming to this. First one regarding rate of reaction or speed of reaction. Based upon time taken, these reactions are classified into three types: slow, moderate, fast. Right? Slow reactions means they will take sometimes months or years for completion. Right? Best example: disintegration of all radioactive compounds like C14. Right? To determine age of fossils, we will calculate by taking C14 disintegration into consideration, we will calculate age of fossils, right? Approximately 6,000 years is the half-life period. So they are very slow. Fast reactions means they goes to completion in fraction of a second. Example, precipitation reactions, right? Neutralization reactions, these are all very fast, right? So in this chapter, we are not much worried about slow or fast. We will study or we will concentrate majorly on moderate reactions. So what are moderate reactions means? Reactions which goes to completion in a measurable time, or we can see measurable change in concentration in a measurable time. So we call them as moderate reactions. So our chapter is majorly we are focusing on moderate reactions, right? So in that moderate reactions, we are studying speed. So first I am not writing all this stuff. Have slow reactions, moderate reactions, fast reactions, and so on, right? Best I will do one thing. Fast reactions, example. Or what are fast reactions? Which goes to completion in fraction of second. Goes to completion in a fraction of second. So to study such reactions, we will follow special techniques. We call them as fast breeder techniques. Right? Example for fast reactions are precipitation reactions. Precipitation reactions. I'm taking an example of precipitation reaction as AgNO3 with NaCl. Immediately it will precipitate AgCl and NaNO3, precipitation reaction. Right? AgCl got silver chloride, white color silver chloride gets precipitated. Right? So we call it as precipitation reaction. Remaining all are aqueous, soluble in water, only this is the precipitate obtained. In the same way, neutralization reactions. You already know now. Neutralization means acids react with bases to form salt plus water. We call them as neutralization reactions. Example, I am taking HCl aqueous react with NaOH aqueous to form NaCl aqueous plus H2O. Right? So these are examples of fast reactions. Right? Slow reactions mean slow reactions. They goes to completion. Maybe in weeks or years or maybe months, etc. Example, nuclear disintegration reaction of C14, right? Moderate reactions. Moderate reactions, we can see measurable change in concentration, measurable change in concentration in a measurable time. In a measurable time. We call them as moderate reactions, right? So we can measure time as well as measure change in concentration. Then we call them as moderate reactions. Examples, whatever reactions you are studying, all are examples of moderate reactions. N2 plus 3H2 in presence of iron catalyst, right? Molybdenum acts as a promoter in olden days. Nowadays, we are using oxides of potassium and aluminum as a catalyst, right? Example, we call this reaction as Haber's reaction or Haber's process. We call that processes at optimum temperature and optimum pressure, right? So this is an example of moderate reaction. As such, whatever reaction you are studying, most of the reactions comes under moderate, right? Now I am coming to our first study. What is it? What is it? Rate of a reaction, right? In that we discussed about two things now: average rate, instantaneous rate. So first I am taking the side heading rate of a reaction. Under that first one, average rate. Average rate means change in concentration of reactants upon change in time, or change in concentration of products upon change in time, right? Change in concentration of reactants upon change in time. We can write simply as delta T. Here also you can write as delta T simply, right? Upon change in time. Per unit change in time, what is the change in concentration of reactants or change in concentration of products, right? We call it as average rate. What happens to change in concentration? As a reaction proceeds, what happens to concentration of reactant? Decreases, product increases. So if I see any graph, if I see any graphical representation for it, concentration of reactants decreases with the time. Concentration of reactants decreases with the time. I am plotting a graph between concentration versus time. Right? Now at time T1, let the concentration be C1. At time T1, let the concentration be C1. At time T2, let the concentration be C2. Right? Instead of reactants, if I take products, how the graph represents? How will be that graph? If it is products, what happens to concentration of products with the time? Increases. So can I write like this? Initial concentration of products is 0. As time proceeds, concentration of products increases. Can I write like this or not? Response, sir. So at time T1, let the concentration of products be C1. At time T2, let the concentration of products be C2. Right? Now tell me what we will write average rate as. Average rate equal to final change in concentration means final concentration by initial concentration. No? Sorry, final concentration minus initial concentration upon final time minus initial. So what is final concentration? C2. So I am writing C2 minus C1 upon T2 minus T1. Correct, sir? Now, if I take reactants into consideration among C1, C2, which is higher value, means this becomes a negative. Correct or not? So I am writing this value as which is equal to minus delta C upon delta T. Will you accept it or not? Are you able to understand why I am writing this negative sign? What is negative sign indicates? Decrease in concentration. Clear? This negative sign indicates decrease in concentration. Because among C1, C2, C1 value is high. So C1 value is high means this difference becomes negative. That's why I'm taking minus. In the same way, if I talk about products, then what is average rate? Here also I will write the same. C2 minus C1 upon T2 minus T1. Now what about C2 and C1 values? C2 is greater than C1, so value becomes positive. So here I will write as delta C upon delta T. What you understood? If I am measuring average rate in terms of reactants, you will get negative. If I rate average rate in terms of products, I will get that value positive. Any questions in it? Right? So positive, we will take average rate as positive if it is a products. If it is reactants, I will take that value as negative. Why I am taking negative means concentration is decreasing. Their concentration is increasing. Any questions in it? I am taking one example now. Right? So I am taking one example. A moles of A react with B moles of B to form C moles of C plus D moles of D. This is the reaction. Now, what is average rate formula? What is average rate equal to? What you will write? Average rate equal to. Now I have stoichiometric coefficient. If there is no stoichiometric coefficient, I will write in a different way. When the stoichiometric coefficient is there, it goes to the denominator. For example, let me explain this. Let me explain this. I am taking N2 react with H2 to form ammonia. Right? Now, when 1 mole of N2 reacts, how many moles of H2 will react? When 1 mole of N2 reacts, 3 moles of H2 reacts, means which is reacting quickly. Number of moles of hydrogen is reacting, amount of hydrogen reacting is more compared to nitrogen. How many times more? That's why I'm writing rate of reaction of H2 is 3 times more than rate of reaction of N2. Correct or not? When 1 mole of N2 reacts, H2 should react 3 moles, na? So meaning of that is rate of reaction of H2 is 3 times more than rate of reaction of N2, right? Or can I write as rate of disappearance of H2, rate of disappearance of H2 is 3 times more than rate of disappearance of N2. Will you accept this? Rate of disappearance of H2 is 3 times more than rate of disappearance of N2. Correct? Right? Any questions here, mate? Now, in the same way, what about ammonia? In the same way, rate of appearance of ammonia, rate of appearance of ammonia is 2 times more than rate of disappearance of N2. Accepted or not? Will you accept it or not? Rate of appearance of ammonia is 2 times more than rate of disappearance of N2. When one N2 disappears, 2 NH3s will form, na? So appearance speed of ammonia is double that of disappearance of N2. Correct? Any questions in it? Clear or not? So I am writing that in mathematical form. So from here, observe what I am writing. Disappearance means concentration is decreasing. So I will take negative sign. Correct? So minus delta H2 upon delta T. Correct, sir? Minus the speed of H2 means change in concentration of H2 by change in time. I am taking minus because it is decreasing. So minus delta H2 by delta T is 3 times of, that is also disappearance. So that is also negative. So minus delta N2 by delta T. Accepted, sir? Do you have any questions in it? Can I write it or not? Now, what about the second case? Tell me about the second case. NH3. Whether I take negative or positive, because appearance, concentration is increasing. So positive. Delta NH3 by delta T is equal to, what you will write? 2 times of minus delta N2 by delta T. Any questions? Right? Now, from first equation, can I write minus delta N2 by delta T is equal to what you can write as 1 by 3 times of this is equal to 1 by 3 times of minus delta H2 by delta T. Accepted or not? Correct? Now again, see the second equation. What you will write? Minus delta N2 by delta T can be written as 1 by 2 times of, means directly can write is equal to 1 by 2 times of delta NH3 by delta T. Accepted or not? Respond, sir. Correct or not? Instead of writing all this, observe the stoichiometric coefficient. What is stoichiometric coefficient of N2 here? 1. So I am writing 1 in denominator. What is stoichiometric coefficient of hydrogen? 3. I am writing 3 in denominator. Stoichiometric coefficient of ammonia? 2. Simply I am writing 2 in denominator. So instead of writing all these things every time, directly can I write this formula or not? Now in the same way, you tell for this above reaction, what I have to write? What I will write now? 1 by A. Negative or positive? Reason? Reactant. So I will write minus delta A upon delta T is equal to 1 by B into minus delta B by delta T, correct, sir? Is equal to product. So I will take it as positive. So 1 by C delta C by delta T is equal to 1 by D delta D by delta T. Any questions in this? Online respond. Do you have any questions in this? Understood or not?
Sir. No, sir.
Clear? Huh? So if you have a stoichiometric coefficient, write the stoichiometric coefficient in denominator and write that reaction. Simple. If it is reactant, take negative. If it is product, take positive. Clear? Any questions in case of average rate? Do you have any questions in average rate? What are the units of average rates? What are the units of average rate? Change in concentration by change in time. So what are the in denominator? Time. Numerator? Concentration. Change in concentration means concentration units only. So what are the units of it? Moles per liter per time. Right? So average rate units is, here I am writing, mole per liter per time. Correct? Any questions? Done? No. This is about average rate. This is about average rate. Now the second thing, what is it? Instantaneous rate. Right? Average rate means total change in concentration by total time taken. Instantaneous rate means what is the change in concentration at a 10th minute, 12th minute, 15th minute, means exactly at that particular time, what is the speed? That is called instantaneous rate. Average rate means, for example, if I am moving from here to my home, right? Total distance traveled is 10 kilometers. So time taken is 10 minutes, assume. Then what is average speed? Total change in distance by total change in position by total time taken. Right? Now, what is my instantaneous speed at 5th minute, 4th minute? Are you able to understand? So we call that as instantaneous. So I am taking that side heading, instantaneous rate. Instantaneous rate. Observe, sir. This is limit delta t tends to 0, average rate. We call that as instantaneous rate. So consider average rate only. But in that, what we have to do? We have to apply one limit. What is it? Huh? What we need to do? Change in time is negligible. And when change in time is negligible means at that particular time, what is the rate? It is called instantaneous. Instead of writing this, can I write limit delta t tends to 0, delta c upon delta t. Or we can also write it as, or we can also write this as or we can also write as dc upon dt. Why am I taking differentiation? Infinitesimally small change in concentration upon infinitesimally small change in time. Clear? So we can write as delta c by delta t. Instead of that, if I write dc by dt, it becomes instantaneous rate. Clear? Any questions in this? Right? Units remains the same. Concentration units by time units. Moles per liter per time. So there is no change in it, right? Now, if I want to see it graphically, if I want to see this graphically, now observe, sir. I am taking exactly at this time. Delta t tends to 0 means what is the gap between T2 and T1? Means both points become single point now. Correct or not? Difference between these 2 points is approaching 0 means now both points becomes single point. Correct? So at that single point, we need to find. Clear? So how to find it? Just draw a slope. Over. I am taking this angle as theta. I am taking this angle as theta. Alright. This as theta. Then what is tan theta? Okay. Someone is doing something, man. If there is disturbance continuously. So I am sharing these notes or what? Okay, let it be. So instantaneous rate is nothing but equal to slope of the curve, which is nothing but equal to minus tan theta. Okay, I have taken theta this side now, so I will take it as tan theta. or it is greater than 90, na? So obviously it becomes negative only. Correct or not? Response, sir. Right? So any questions regarding instantaneous rate and average rate? Now the same reaction I am writing. Then what will be instantaneous rate for this? Same example I am taking. For this example, what is instantaneous rate? Response, sir. What is instantaneous rate now? Minus dN2 by dt is equal to 1 by 3 minus d of h2 upon dt equal to 1 by 2 d NH3 by dt. Correct, sir? Any questions in this? Right? Units must be moles per liter per time. If they gave units in terms of grams, convert them into moles, do the calculation, and after getting the final answer, again convert them into grams. If they gave some question to solve that in terms of grams and I want the answer also in terms of grams, then what I have to do? First, I convert grams to moles, do the calculations. Then in final answer also you convert that into grams and submit the answer. Clear? So we have to do all these things in moles per liter per time. Be cautious. Clear? Any questions, sir? So we are done with these two words. Average rate, instantaneous rate. So first part is over. Now I'm going to the second stage. Second stage. What is it? Law of mass action. Right? Now serious. Law of mass action. Right? Right. Here you need to know one more concept. In chemical equilibrium chapter, we discussed about active mass. You remember? What do you mean by active mass? Activity coefficient gamma into concentration, right? Let it be a note. Active mass is equal to activity coefficient gamma into concentration. For our syllabus or in our study, we are considering activity coefficient gamma as 1, right? This is activity coefficient gamma. Right? Active mass can also be written as number of moles upon volume in liters. Number of moles upon volume in liter. Nothing but concentration only, na? Right? And it is a dimensionless quantity. Active mass is a dimensionless quantity. Means what are the units of gamma? Reciprocal to the units of concentration. The gamma units is reciprocal units of concentration. Then what happens to overall units? Are you able to understand? So if gamma is equal to 1, then if gamma is equal to 1, then what happens? Active mass becomes equal to concentration, right? So what is concentration? Moles per liter is concentration, na? So that's why I directly wrote active mass as moles per liter. Clear? Any questions, sir? In our syllabus, we don't have this gamma term and so on, right? So we don't have this term. Instead of substituting active mass, we will directly substitute concentration. right? So leave that case. Just know it and leave it. Now coming to this. So according to law of mass action, rate of any reaction is directly proportional to product of means multiply product of concentrations of reactants whose exponents means powers, or I will write whose powers are raised to their molecularity. Powers or exponents are raised to their molecularity. For any reaction, I am taking one example. If I consider a reaction in this way, A moles of A plus B moles of B gives rise to products. If this is the reaction. Now, according to law of mass action, what is rate of reaction now? Rate of reaction is proportional to, I need to multiply concentration terms of reactants. So concentration term of reactant A, I am writing like this. Reactant B, I am writing like this. And their exponents are raised to their molecularity. So power A, power A power A, B power B, right? That means I can write as rate equal to some proportionality constant K into concentration of A power A into concentration of B power B, where this K is called as rate constant. That K is called as a rate constant, or we also call it as specific rate. I am calling it as specific rate means I need to specify something. I am specifying concentration of A, concentration of B as 1 molar. If I specify their concentrations as 1, then what happens? 1 power A into 1 power B. So total term becomes 1. If total terms becomes 1, then what is K? K becomes equal to R. Correct or not? So then that's why I am calling it as specified rate. If I specify their values, then it becomes equal to rate. That's why we call it as specific rate. Clear? Any questions in it? So rate equal to K into concentration of A power A into concentration of B power B. Now tell me what are the units of rate constant? What are the units of rate constant now? You know the units of rate? What are the units of rate? Units of rate, mole per liter per time is equal to K into, what are the units of A and what are the units of B? The concentration term, na? So moles per liter power A, moles per liter power B. So can write as mole per liter power A plus B. Correct? Now bring that to this side. If I bring this term to this side, what you will get? Mole per liter whole power 1 minus A minus B. Correct? I am bringing this term to this side, man. Moles per liter power 1 minus A minus B. So instead of writing that as A minus A minus B, I am writing it as N per time, where N is nothing but equal to A plus B, which is nothing but called as order of a reaction. Any questions are in that? Right? and one condition is here. I can call this as order of a reaction if it is elementary reaction. If it is elementary reaction, then only I call it as order of a reaction. If it is not an elementary reaction, I cannot call it as order. So to understand that, first we will see what is elementary reaction, how to find order, what is molecularity, and so on. Right? So just this is about law of mass action. Right? So according to law of mass action, what I have to write? Rate is proportional to concentration of reactants. We need to multiply, and their power should be raised to their molecularity. Simple. Clear? Respond, sir. So now we are going to see the next term. What is it? Under law of mass action, what we need to study? Molecularity, order, rate constant. Just now we have seen rate constant. We need to see about molecularity and order. Right? So I'm taking next heading, molecularity. First we will see what is molecularity, then we will see what is order. Right? So molecularity of a reaction. Yes, sir. No. I am writing it as a time. Here you are saying this one. Yes, this is time power minus 1. Right. If n is 0, if n is 0, if n is 1, whole term becomes time power minus 1. Right. Now coming to molecularity. Molecularity means number of molecules collide with each other, right? At any instant of time at a single point. That is called molecularity. Number of molecules make a collision with each other at any instant of time at a single point. We call it as molecularity of a reaction. So molecularity means number of molecules collide at any instant of time is called molecularity of a reaction. This can never be greater than 3. It can never be, can I write like this? What is the meaning of it? What is the meaning of it? Never be greater than 3. It can never be equal to 0. It can never be negative, fractional, imaginary. It can never be negative. It can never be fractional. It can never be imaginary. Right? So molecularity of a reaction always equal to molecularity equal to either 1 or 2, rarely 3. Reason? Molecules which are making collision with each other. How many molecules will collide with each other? Collision will be 2 only. Right? Imagining 3 molecules making collision with each other at the same point at same time is imaginary only. Are you able to understand? So that's why I will say 3 is practically, thinking about 3 is practically not possible. So greater than 3 is impossible. 0 means 0 molecules make collision with each other. How 0 molecules collide with each other? Half molecule will collide with each other. That things doesn't exist. That's why molecularity will be either 1 or 2. 3 also benefit of doubt. Greater than 3 is impossible. So this is about molecularity, right? Clear? When you are calculating molecularity means if and only if that reaction occurs in single step, then only you can calculate molecularity. Clear? Are you able to understand? If a reaction occurs in single step, this molecule make collision to form product over. That is called one step. Then what is molecularity? You are considering two molecules, so molecularity becomes, right? The moment I say something about molecularity means I am studying only one step or single step reaction I am studying, right? If a reaction occurs in two steps, step one have one molecularity, step two may have another molecularity. For every step we have to study molecularity. Are you able to understand? Clear or not? So molecularity of a reaction means I am studying that only for a step, single step. If a total reaction occurs only in one step, then I call it as elementary reaction. Clear? So molecularity is calculated for every step. Can be considered for every step. Right? If I am considering studying molecularity means I need to study that molecularity for every step. Right? If a reaction occurs in single step, if a reaction occurs in single step, we call such reaction as elementary reaction. In elementary reactions, order and molecularity both are equal. As of now, we know what is molecularity. Now we will see what we mean by order, right? Then we will see how they become equal, right? So if a reaction occurs in single step, directly we will calculate molecularity. That molecularity itself is equal to order, right? Now we will see what is order of a reaction. Any questions are under molecularity? Now come to order of a reaction. To find molecularity of a reaction, if you see reaction, we can say what is molecularity. But order cannot be given by seeing a reaction. It has to be found experimentally. If you don't know the experimental method of a reaction, it is impossible to calculate order of a reaction. That's why molecularity is a theoretical way. Order of a reaction is a experimental. Clear? So order of a reaction is found experimentally. Right? Experimentally means I need to know what is the mechanism of a reaction, whether the reaction occurs in one step or two steps or three steps. I need to know complete mechanism of the reaction, right? So order of a reaction is found is determined from rate expression. Rate expression is obtained. Rate expression is obtained from reaction mechanism. If you know the reaction mechanism, in that slowest step is rate determining step. Slowest step is rate determining step. So, 9 to 6, madam. Yes, madam. Slowest step is rate determining step. From rate determining step, we will write rate expression. From rate expression, we will find order of a reaction, right? So, what is order of a reaction in rate expression means sum of exponential terms. Exponents means powers, right? Sum of powers to concentration terms in a rate expression. Is equal to order of a reaction. Is equal to order of a reaction. Means, for example, if I write a rate expression as R equal to K into concentration of A power M into P power N, then order equal to M plus N. Better I will write as X, Y. Therefore, order of reaction N equal to. Therefore, order of reaction N is equal to X plus Y. If and only if I call this as rate expression. If I call this as rate expression, then only that X plus Y is called out. Now the question is how can I find whether it is rate expression or not? Right? To write that rate expression, we have two methods. One is called intermediate method. Second one is called steady state approximation method. We have two methods: steady state approximation method, intermediate method. Intermediate method is present in our syllabus for mains. Steady state approximation we need to study if you want to solve problems of atoms. So that's why we will see both by taking one example, right? For example, I am studying decomposition of ozone. I am studying decomposition of ozone. It occurs in two steps. Step 1, ozone gives rise and form O2 plus nascent oxygen. This is step 1. Step 2, ozone again combined with nascent oxygen to form 2O2. Combination of both reactions is overall reaction. That overall reaction is 2O3 gives rise to form 3O2. This is overall reaction. This is that overall reaction. Right? Now, in this, first step is fast step. Second step is slow step. Now, what we discussed, which step is rate determining step? Slow step is rate determining step. Therefore, rate of reaction is proportional to concentration of O3 into concentration of O, because the step 2 is slow step, right? So I want to write rate expression by using slowest step only. So because slow step is rate determining step. Is it clear? And second condition, in your rate expression, there should not be any intermediates. But problem is here we have intermediates. I need to eliminate it. I need to eliminate this intermediate. After eliminating that intermediate, whatever the expression we got, that is the final rate expression. From that rate expression, if I add powers, then it is called order. How to eliminate this intermediate? We follow two methods. Intermediate method, steady state approximation method. Clear? Now, whether decomposition of ozone occurs in single step or many steps? Decomposition of ozone occurs in how many steps? 2 steps. Or overall reaction, and this is step 2. So it occurs in 2 steps. If any reaction occurs in single step, then it is called elementary reaction. So for step 1, what is molecularity? 1. For step 2, molecularity 2. Okay. Molecularity means how many molecules involved? That is called molecularity, na? For every step we have molecularity, but order is different. Is it clear? Order is found from final rate expression. Molecularity can be found by seeing the reaction. Clear? So molecularity for step 1 is 1. Molecularity for step 2 is 2. Clear? What is the molecularity for overall reaction? 2. Molecularity for overall reaction? 2. Or 2 moles of ozone is involving, na? Correct? Response, sir. Any questions in it? But overall molecularity is different, but order is different. To find order, I need to know reaction mechanism and I need to calculate rate expression. Now, here this is intermediate. So I need to eliminate it. Can I call decomposition reaction as complex reaction? Decomposition of ozone as complex reaction? Why I am calling it as complex reaction? It is not elementary, it is complex reaction. Why I am calling it as complex reaction? Reactions which occur in more than one step. Hey. Again, chemistry only. Now listen. So reactions which occur in more than one step is called complex reaction. In that complex reaction, whichever is the slowest step, from that slowest step, I need to write rate expression. If rate expression has intermediates, I need to eliminate. To eliminate that intermediate, we have two methods. One method is intermediate formation method. Second method is steady state approximation method. Intermediate formation method, steady state approximation. Among them, this method is more accurate. Right? It is always more accurate. But problem is for our syllabus, we have this one. Right? So we will see both. Now coming to this. This reaction is occurring in two different steps. First step, O3 gives rise to form O2 plus O. Right? Now, I am writing that this reaction is occurring in forward direction as well as backward direction, equilibrium reaction. So if I write only forward reaction, I have to write O3 gives rise to O2 plus O. Correct? Apply law of mass action for it. According to law of mass action, what I have to write? rate is equal to rate constant K into O3. Correct, sir? So rate equal to rate constant K into O3. For backward reaction, what I have to write? Backward reaction. I will write like this or not? O2 plus O is equal to O3. Correct? Huh? Right. This reaction is occurring in forward as well as backward. For forward reaction, I wrote like this. For backward reaction, what I will write? R equal to K into O2 into O. Response, sir. Why I am writing that? Because now these two becomes reactants, no? Correct? So for forward, let me consider its rate constant as K1. For backward, let I consider this rate constant as K minus 1. Clear? I will write as rate of forward, this as rate of backward. In chemical equilibrium chapter already you studied. For any equilibrium reactions, always rate of forward becomes equal to rate of backward. Correct? If rate of forward and rate of backward both are equal, what I will write? We know that rate of forward is equal to rate of backward. Means what I will write? K1 into O3 is equal to K minus 1 into O2 into O. Correct, sir? To make you to understand, let me write here K1. Let me write here K minus 1. Here I am writing K2. What are the K1, K minus 1, K2? Rate constants. Clear? Response, sir. Now from here, what is K1 by K2? Or K1 by K minus 1. What is this K1 upon K minus 1 equal to? O2 into O upon O3. Correct, sir? Equilibrium only, man. That implies what is O equal to nascent oxygen concentration equal to K1 into O3 upon K minus 1 into O2. Now substitute this O term in rate expression. Substitute that O term in that rate expression. And then what you will get? And this is rate expression, na? So substitute that O term in this rate expression. What you will get then? What you will get? Therefore, rate expression R equal to what I will write? This is slow step, man. Right? So let me write this. Therefore, R equal to, can I write K2 into O3 into O? Correct or not? Why? The proportionality constant, man, rate constant. What is rate constant for slow step? K2. That's what I'm writing. Clear? Say something. So this is a rate expression. I am substituting this nascent oxygen value in that rate expression. We got the nascent oxygen value. This I am substituting here. Right? So what you got now? R equal to K2 into O3. Correct? Instead of O, what I have to write? Instead of O, K1O3 upon K minus 1 O2. Correct? Is there any intermediate term now? Is there any intermediate term now? Only reactants and products are there. So perfect rate expression. So what you can write? Therefore, rate equal to what you will get? K2 K1 upon K minus 1. I am writing that as capital K. A constant into constant by constant is nothing but constant only, na? So I am writing that as R equal to constant K into what do you have? O3 power 2 into O2 power minus 1. So this is final rate expression. Now add powers. If I add powers 2 and minus 1, what you will get? Order. So what is order of reaction now? 1. With respect to O2, what is the order? -1. With respect to O3, 2. Overall, 1. Is it clear? So order of reaction, that implies order of reaction with respect to O3 is 2 with respect to O2 -1 overall order 1. Therefore, can I say decomposition of ozone follow first order kinetics? Clear? Any questions, sir? Done or not? Right? So, if you know reaction mechanism, by taking slow step, we have to write rate expression. If that rate expression has intermediate, we need to eliminate that intermediate. After eliminating whatever the expression is obtained, that is the final rate expression. In that rate expression, if I add powers, then I will get overall order of the reaction. Clear? So I cannot find order of reaction without knowing overall rate expression, correct? How I will get this overall rate expression? Only from reaction mechanism. How I will find overall reaction mechanism? Experimental. That's why order of reaction is found only by experiment. If I don't know experiment, if I don't know reaction mechanism, I cannot find order. That yes means that's what I'm saying. Means it is an elementary reaction. If I am writing single step, here whether I wrote single step or many steps, means it is elementary reaction. If it is elementary reaction, order and molecularity are. If it is elementary reaction, order and molecularity are same. Over. Done. Any questions? Now, coming to steady state approximation. Steady state approximation says that net change in concentration of intermediate. Net change in concentration of intermediate is 0. Net change in concentration of intermediate is 0. Means amount of intermediate formed, amount of intermediate gone will be always same. Means what is the net change? 0. Over. Now, by using this idea, we are going to bring one derivation. By using this idea, we need to bring one derivation. Now see this. This is the overall reaction, right? This is the overall reaction. Okay, wow. Now, step 1, occur in forward direction as well as backward. So I am considering only forward. Means what it will be? O3, K1, O2, O. Correct, sir? Correct or not? What is instantaneous rate formula? What is instantaneous rate? How I will write instantaneous rate for this? Minus d O3 by dt is equal to d O2 by dt is equal to dO by dt. Is nothing but rate. Correct, sir? Instantaneous rate. Yes or no? Right. According to law of mass action. According to law of mass action, what is rate for this? According to law of mass action, K1 into O3. Response, sir. This is according to rate. This is according to law of mass action. Both are equal only, no? Both are talking about rate only. So rate according to law of mass action can be written as this. Rate according to instantaneous rate can be written as this. Correct? Yes or no? Now coming to second one. What is second step? Backward. Can write as K minus 1, O2, O, O3. Response, sir. Now again, write instantaneous rate formula. Now this will be product, these two are reactants, now. So what I'll write? D O3 by dt equal to minus dO2 by dt minus dO by dt is instantaneous rate. Now apply law of mass action. K minus 1 into O2 O. Right, sir? Because this is reactant and this is product now. Now I am taking third step. What is third one? Means step 2. O3 plus O 2O2. Correct? What is instantaneous rate? Minus d O3 by dt is equal to minus dO by dt is equal to 1 by 2 dO by dt. Correct? dO2 by dt. Right? Is rate. Law of mass action. This is K2 now we have taken. Now K2 into O3 into O. Correct, sir? Now, in steady state approximation, what we have to write? D of intermediate by dt must be taken as 0. Correct? Response, sir. Net change in concentration of intermediate must be equal to 0. Net change in concentration of intermediate. Net change in concentration of intermediate means changes in all steps. If I add, then I will get net change in concentration. Correct? What is intermediate here? Nascent oxygen. Means this. If I add all those three, then I will get net change. Correct? So now tell me what is net change in concentration of intermediate dO by dt equal to? Write that equation. What is dO by dt? Net value. The sum of all these three now is the net change. Now what is it? K1 into O3 minus K minus 1 into O2 into O minus K2 into O3 into O equal to 0. Correct, sir? Right or not? This is change in concentration of O only in first forward step. This is change in concentration of O only in backward step. This is change in concentration of O in second step. What is the overall change in concentration of O means? I need to add all. I am adding all the three. According to steady state approximation, this must be equal to 0. Correct? If this is 0, what I will write? K1 into O3 equal to K minus 1 into O2 into O plus K2 into O3 into O. Correct, sir? Yes or no? Right? Say something.
Sir,
Yes, sir.
why that is 0, sir?
Hey, what happened to intermediate, man? Common sense, man. Intermediate is forming and intermediate is decomposing. What happens to intermediate's concentration now? It remains constant. But it is forming and it is decomposing means obviously it remains constant, no? Then what is net change in it?
What?
0. That's what we are writing. If it is not 0, if net change is not 0, what happens? Either only intermediate will exist or intermediate will never form. Correct or not? Response, sir. Right. Now see this. Instead of writing all this nonsense, just by looking at the reaction, can I write it? Just by looking at it. This is the intermediate. So for this intermediate, I am writing dO by dt equal to in forward reaction, O is forming or not? If O is forming, this dO by dt becomes positive or negative? Positive. This is positive is what is law of mass action for forward? K1 into O3, positive. Correct? Now for backward, what happens to concentration of O? Decreases. Means it is negative. So according to law of mass action, negative of array backward K minus 1 O2 into O. Correct, sir? For backward. For backward. O2 into O. And we are talking about concentration of O. It is decreasing, so negative. Now in third step, O is decreasing or increasing? Decreasing means again negative. Apply law of mass action. K2 into O3 into O. Whether we get the same thing or not. Whether we are getting the same thing or not. Right? So to write that reaction is nearly necessary to do all this stuff. Just directly we can write it. Correct? Now what about this value? Then bring these negative terms to this side. What do you get? K minus 1 into O2 plus K3 into O3 into O equal to K1 into O3. Correct, sir? Respond. Now what is O equal to? K1 O3 upon upon K minus 1 into O2 plus K3 into O3. Now substitute this in. Substitute this O term in rate expression. Right? Then what is rate equal to? Then what is rate equal to? Or if I substitute this term, can I write K1 K2 O3 square divided by, correct? So therefore rate equal to K1 K3, sorry, K1 K2 O3 square upon K minus 1 into O2 plus K3 into O3. So this is the rate expression according to steady state approximation method. Now here I am applying different conditions. Wait, not K3, man. I wrote this as K3, yeah. I have to write this as K2. I'm writing this as K2. Here also I'm writing as K2. Done? Right? Now, here I'm applying one condition. Observe this reaction mechanism. Which is fast step, which is slow step? First step is fast, second step is slow step. Means among K minus 1, K2 value, which is higher value. Among K minus 1 and K2, which is higher value. K minus 1. So I am applying that condition. If K minus 1 is far higher than K2, what happens? If K minus 1 is far higher than K2, what happens to this denominator? This becomes negligible and it becomes K2 into 3. Then it is nothing but this reaction only. Response, sir. Means intermediate method is one of the case of steady state method. Clear? So if K1 is greater than K2, expression is the same as intermediate method. So I am writing decomposition of ozone follow first order kinetics. Over. Right? Now tell me how to find order. How to find order? First, we need to find rate expression. After finding rate expression, only we can find order. Now tell me, order of reaction can be 0, possible or not? Or if I am adding 1 as 1 and -1 both came, then what is order? 0. So order of a reaction can be negative, positive, 0, fractional. Right? But molecularity will be always 1, 2, 3. Order can be anything. But don't write imaginary terms, sin theta terms. Such things will not be. No trigonometric functions. Right? Remaining all are possible. Clear? Any questions, sir, in this? So we are done with order and molecularity and rate constant. Clear? So second part is over. These two things are over. Now we need to study about integration method of determining rate constant. Right? So we are going to see this intermediate method of determining rate constant. Yes, sir. All right, go for break and come back within 5 minutes, man. Okay. Online students, you will join in second link. Go for break, come back within 5 minutes, join in the next link. And one more thing, sir, if you complete intermediate method now, hey, what I wrote? Integration method, not intermediate method. Huh? Integration method. If this part is over now, 75% of the chapter is over. If this part is done, 75%. Right? Over. Come back within 5 minutes, sir. Join in the next link. Rate of formation of NH3 is 2 into 10 power minus 2. Then what is rate of consumption of N2? Half. Rate of consumption of N2 is half of rate of formation of NH3. Correct or not? So what is the value? Say something, man. What is that value? Done. Any confusion in it? Online? You have any confusion here?
No, sir.
Solve these two. Solve question number 4. Rate of a gaseous reaction is given by the expression K into A into B. Right? They are saying that R is equal to K into concentration of A into concentration of B. What they are saying? If a volume of the reaction vessel is doubled, sorry, not doubled, okay, is suddenly reduced to 1/4 of initial volume. If I decrease volume, what happens to concentration? Increases. Correct? Whether you are increasing volume or decreasing volume. How many times? Right? So, what is concentration, sir? Concentration means moles upon volume. Now, instead of volume, what I have to write? Volume by 4. Correct? If instead of V, if I write V by 4, what I have to write? 4 times of mole by volume. Means what happens to concentration? Increases by 4 times. Correct, sir? So, what I have to write? Means R1 is equal to, now new rate, I don't know. K into, what happens to concentration of A now? 4 times of concentration of A. What about B? 4 times of concentration of B. So what I will write? R1 equal to 4 4s are 16 into K into concentration of A into concentration of B. What is this K into concentration of A into concentration of B can be written as R. Response, sir. Means what is new rate? R1 equal to? R1 is 16 times of R. So rate increases by paste question. Correct? Now come to the next one. Oh, this you cannot solve. Because they are talking something about activation energy. As of now, we have not yet discussed that concept. Right? That not yet discussed. So I will stop that. We will discuss that part later. Let me see few more questions. Over. Up to here. Except question number 5, remaining things are over. Now come to next one. What is next one? R and molecularity. Both are done or not? Say something, sir. Right? What is this R equal to dx by dt means? Instantaneous rate. R equal to K into this term means law of mass action. They are equating both. Clear? Done or not all these things? We need to discuss about pseudo unimolecular reaction that I will discuss now. All right. After that, molecularity of a complex. What are complex reactions? Then how you will find molecularity? You have to find molecularity for every step. Correct? Now, what is molecularity for this step? 3. Here, 2. Here, 3. Now, what is overall? 5. But you should not say. Reason. This is not single step reaction, na? This is overall reaction, man. This is overall reaction, but that reaction will not occur in single step. It occurs in 3 steps. For every step, I have to give molecularity, but not for the overall step. Clear? Now, among these 3 steps, whichever is slowest step, for that, I have to write rate expression. From there, I will calculate R. Response, sir. Now, after that, we will go for that we need to discuss. Right? Not yet discussed, we have to discuss that. After that, we have to go for exercise, right? Now, before going to this expression, they gave one side heading. What is it? Pseudo unimolecular reaction. So first I will take that side heading and I will come back. Okay. So first we are discussing about pseudo unimolecular reactions. Now listen. In one reaction, if any one of the reactant is excess in quantity, right? If one of the reactant is excess in quantity, if something is excess, what you will write K equilibrium? In K equilibrium, you will write concentration of reactants by concentration of products. In that, if something is excess, what you will write? 1 in its place. You will write 1 or not? In case of solids, then also activity you will take it as active mass, you will take it as 1. Correct or not? In case of gaseous reactions, if liquid is present, then also I will take it as 1. Right? So if we have any excess amount of reactant, in case of excess amount of reactant, in this case, concentration of reactant is independent. Or I will write rate of reaction is independent of rate of reaction is independent of concentration of reactant. Independent of concentration of reactant means what I have taken. What is the power I have taken? 0. And it is independent of concentration of reactant means I have taken its power as 0. For example, CH3, CO, O, CH2, CH3. What we call this as? Ethyl ethanoate. Correct, sir? Ethyl ethanoate. Ester we call it as. Right? This aqueous solution I have taken in presence of water. In acidic medium undergoes hydrolysis to form acid plus alcohol. We call this reaction as hydrolysis of ester. In what medium? Acidic medium. Hydrolysis of ester in acidic medium. Right? Let me assume its rate constant as K. Therefore, what is rate expression? Therefore, what you write? Rate of reaction equal to rate constant K into concentration of ester, right? Power 1 into concentration of water. I have to write power 1 generally. But this is taken in aqueous medium and water is also taken. Means, what is the meaning of it? How this is present in water means already water is in excess quantity. If it is excess in quantity, what happens to concentration of water? Power becomes 0, means concentration of water becomes 1. Reason, this is excess in quantity. Clear? By looking at this reaction, what is the molecularity of reaction? 2. Correct? Response, sir. So, molecularity of this reaction, seems to be 2. But follow. But it follows first order kinetics. Such reactions are called as pseudo unimolecular reaction. Is it clear? Molecular seems to be different, but order is first order. Means if some of the reactants are excess in quantity and if it follow first order kinetics, then we call such reactions as pseudo first order reactions or pseudo unimolecular reactions. I am taking one more example. One more example. Inversion of cane sugar. Inversion of cane sugar. The sugar means sucrose. What is it? C12, H22, O11. Aqueous. It will react with water in acidic medium to form glucose plus fructose. Glucose, fructose have same formula. Here also rate of reaction is equal to rate constant K into concentration of sucrose power 1 into concentration of H2O power 0. So it also follows first order kinetics. Seems to be bimolecular, but actually it is following first order reaction. That's why it is called pseudo unimolecular reaction. If any of the concentration of one of the reactant is excess. Response, sir? Clear? So we call such reactions as pseudo first order reactions. Done. Now coming to next heading, what is it? Integration method of determining rate constant. Now, sir, let me consider one reaction, sir. That reaction is m moles of A gives rise to form products. Let its rate constant is K. Right? Following it is following nth order kinetics. Nth order reaction. We don't know the order of reaction. Let me consider order of reaction as n. Right? Do I wrote that reaction in one step or many steps? Means its reaction is elementary reaction. Then what is its molecularity? M. Order n. I told it as nth order reaction, man. Right? Now what is the value of m and n? Equal. Correct or not? Right? If I write here m and I am saying nth order, and if I say m and n are not equal, then definitely it becomes complex. Is it clear? Now what is this m? M is stoichiometric coefficient. Order is n. M is stoichiometric coefficient. N is order. Right? Now apply instantaneous rate formula. What is rate? What you will write? Therefore, rate equal to therefore rate equal to say sir 1 by m minus dA by dt equal to according to law of mass action K into concentration of A power n. What I told? Nth order reaction. I told it as nth order reaction. So you have to write n. If I say mth order reaction, you will write m. Right? M is stoichiometric coefficient. So for sure I have to write m here. I cannot escape. But I am saying nth order reaction. So I have to write power n. Clear? M is stoichiometric coefficient, N is order. Understood? Any questions, sir? That's why I have not taken NA, nth order. I showed them differently so that don't get confused. Right? Any questions? At a time t equal to 0, let its number of moles be A. After certain time, some amount of A is gone. So what I will write? A minus X. Correct? Can I write like this? Means what is concentration of A at a time t equal to 0? What is this value? What is concentration of A at a time t equal to 0? I wrote it as A naught. A naught means concentration of A at a time t equal to 0. What is its value? A. This is concentration of A at a time t equal to 0. Now, what about AT? A minus X. What is it? Concentration of A at time t equal to t seconds. Correct, sir? Or maybe t minutes. Correct? Time t equal to some t seconds or maybe t minutes. Any questions? No. Therefore, minus dA by dt is equal to m into k into concentration of A power n. Can I write it? Minus dA by dt equal to m into k into A power n. What is m? Stoichiometric coefficient. What is n? Order. Correct? No confusion now. What is the meaning of minus dA by dt? Change in concentration of A. So what we write? Final concentration minus initial concentration. Correct? What is final concentration? Initial concentration. So A minus X minus A. Minus of minus X. So can I write this as dx by dt equal to, correct, sir? Response, sir. And when time is t, change is x. If a time is dt, change is dx. Correct, sir? So dx by dt equal to m into k concentration of A power n. Response, sir? Any questions in it? So I am writing this as term as A minus x power n. Is there anything wrong? Why? If a time t is 0, x will be 0. If time t is not 0, x value will not be 0. If time t equal to t, x value is x. Correct, sir? Respond. Instead of concentration of A, I am writing A minus x. If you say time as 0, I will write x value 0 directly. If x value is 0 means concentration of A becomes A only, na? Say something. Means, can I write this term as dx upon A minus x power n is equal to m into k into dt. Is there anything wrong? No. Integral x value changes from 0 to x when time value changes from 0 to t. Is there anything wrong? When time changes from 0 to t, x value changes from 0 to x. Right? Correct? If a net change in time is a t, then net change in x is x. Clear? Respond. Any questions in it? Now observe this equation carefully. Observe this equation carefully. If n is equal to 1, if n is equal to 1, then what is the equation? Integral 0 to x dx upon a minus x is equal to integral 0 to t m k dt. What is integral 1 upon a minus x? Log a minus x base c and differentiation of a minus x is minus 1. Correct? Response, sir. So can I write as minus log a minus x base c between the limits 0 to x is equal to what is m? Stoichiometric coefficient, that is constant. K constant. So integral dt t between the limits 0 to t. Then what I have to write? Upper limit minus lower limit. So instead of x, substitute x minus 0. So what I will write? ln a minus x minus ln a minus 0. Response, sir. Any questions in it? So I'm writing it minus of ln a minus x upper limit minus ln a minus 0 is equal to, instead of t, I have to substitute upper limit. Okay. I missed that mk. 1 minute. mk t between the limits 0 to t. So mk, what I have to write? Upper limit minus lower limit. So it becomes t minus 0. Response, sir. Now what about this term? Minus ln a minus x plus ln a. Then it becomes ln a upon a minus x. So ln a upon a minus x is equal to mkt. Now k equal to, bring that mt to this side. So therefore k equal to 1 upon mt ln a upon a minus x base c log a upon a minus x base c. Response, sir. This is rate constant when n equal to 1 means first order kinetics. N I have taken it as 1 na? Means if it is first order reaction, this is rate constant. So rate constant k is 1 upon mt log a upon a minus x base c. If it is complex reaction, we don't know, na? If it is elementary reaction, definitely m value becomes 1. If it is complex reaction, m value will not be 1. For both, we have got same k. Right? This is k equation. If the given reaction is elementary, obviously m also becomes equal to 1. If it is not elementary, m value will be equal to m. Are you able to understand? Who told it is single step? Do I took this equation for single step or for rate expression I have taken? Whether it is rate expression or single step. If it is single step, what I will write? Definitely a power m only I will write. I am not writing a power n, I am writing a power n. Means I don't know whether it is single step or more than one step. It is nth order reaction. So I wrote a power n. Clear? Are you able to understand? If you say single step, definitely this n I will remove and I will place m only there. Understood? Clear? Right. Now, If n is not equal to 1, if n is not equal to 1, then what you have to write this equation? Integral 0 to x dx upon, or I will write a minus x power minus n dx integral 0 to t m k dt. Correct, sir? If n is not equal to 1, what I will write? A minus x power minus n dx. Now, what is integral something power minus n? It's that x power minus n plus 1 upon minus n plus 1 and differentiation of this term. Correct? So, what is differentiation of this term? Minus 1. So, minus 1 into a minus x power minus n plus 1 upon minus n plus 1. Correct? Between the limits. What are the limits? 0 to x m k t between the limits 0 to t. Response, sir. Now, bring this negative or take minus 1 common denominator. What do you get? N minus 1. But if I take minus in common denominator, n minus 1. Minus is 1. Correct? So that 1 minus n minus 1 is present in denominator. Bring this a minus x power minus n plus 1 to denominator. Bring that a minus x power minus n plus 1 to denominator. Then what do you get? A minus x power n minus 1. Correct? So both are in the denominator. So I am writing it as 1 upon n minus 1, because I have removed that my negative term. 1 upon a minus x power n minus 1 between the limits 0 to x is equal to m k t between the limits 0 to t. Is there anything wrong? Upper limit minus lower limit. So what do you got? 1 upon n minus 1. I am substituting upper limit. 1 upon a minus x power n minus 1 minus lower limit. The substitute 0, na? So what do you get? A power n minus 1 is equal to m k upper limit minus lower limit. Right? Now what is k equal to? Therefore k equal to. Bring this m and t to this side. 1 upon n minus 1 into m into t into 1 upon a minus x power n minus 1 minus 1 upon a power n minus 1. This is rate constant k equation when n not equal to 1, and that is k equation when n equal to 1. Over. So we are done with integration method of determining rate constant. We found rate constant k equation by using integration. Response, sir. So these two are very, very, very important equations. 50% numericals of this chapter will be given based upon these two equations only. Now, you know half-life. What do you mean by half-life? What do you mean by half-life? Half-life. Symbolically, we write as a t half or t 0.5. means time taken per concentration to become half of the initial amount. Whatever initial amount you have taken, in water time it becomes half. That is called T half or half life. That is, if I write A gives rise to products. If I write A gives rise to products. At a time t equal to 0, let it be A. At a time t equal to T half, A minus X, where X becomes equal to, X is equal to A by 2. That is A minus X equal to A by 2. Correct, sir? X becomes equal to A by 2, A minus X also becomes equal to A by 2. Now, substitute X equal to A by 2 here. Substitute X equal to A by 2 here. If I substitute X equal to A by 2, what happens? A minus A by 2. A by 2, the 2 goes to numerator. 2A by A cancel, ln A. Sorry, ln 2. Right? Log 2 base C. Response, sir. So I am writing when T equal to T half. What happens to this equation? If a time T equal to T half, what happens to this equation? It becomes a 2, log 2. Correct? Response, sir. Bring T half to this side, K to this side. Then a T half equal to 1 upon mk log 2. Response, sir. Respond, correct or not? Right? Now, apply the same principle here. When T equal to T half, what is this equation? T half equal to. Bring this, take this T as T half. Bring the T half to this side, K to this side. So what do you get? N minus 1, M, K. And what about this stuff? Instead of X, A by 2. A minus A by 2 is A by 2. So can I bring the denominator to numerator? So 2 power N minus 1 upon A power N minus 1 minus A power N minus 1. A power N minus 1 common. So what do you got? 2 power N minus 1 minus 1 upon A power N minus 1 into N minus 1 into M into K. $75 first after. Only we have to do one thing. Substitute n equal to 0. Right equation. Substitute n equal to 2. Right equation. Substitute n equal to 3. Right equation. Draw different graphs. Oh. Clear? Are you able to understand? This is for nth order kinetics where n is not equal to 1. If n equal to 1, this is the equation. So that's why these equations we will study in case of first order kinetics. These equations we will follow when if it is not first order kinetics, if it is 0th order or second order or third order, I will follow this. Right? Now, for example, I am taking 0th order kinetics. Right? For example, I am taking 0th order kinetics. zeroth order kinetics. I am writing one zeroth order reaction. A gives rise to products. Zeroth order reaction. Now tell me, is it elementary reaction or not? If it is elementary reaction, what is molecularity? 1. If it is elementary reaction, what is order? 1. But what heading I have taken? Now tell me, do zeroth order reactions can be elementary or complex? Complex. So zeroth order reactions will never be elementary. If it is elementary, order and molecularity must be equal. Correct? If order and molecularity must be equal means I have to write 0. 0 A gives rise to products. Means without taking any reactant, I should get product. How is it possible? Clear? So all zeroth order reactions are complex reactions. Right? Now, what I will write rate expression here. R is equal to, if rate constant is K. Now, what I will write, R equal to K into A power. Whether I write 1 or 0. Because it is not elementary, na? If it is not elementary, I will not write stoichiometric coefficient here. Correct? So A power 0. Correct? If I write A power 0, rate is always equal to K. Means rate of reaction remains constant only in case of zeroth order reaction. Clear? Any questions in it? Means if I plot a graph between rate versus concentration of reactant, how the graph will be? So I am plotting graph between rate versus concentration of reactant at time t. How the graph? And what is intercept? K. Slope 0. Correct, sir? Any questions? Right? If n is 0, n is 0, order is 0. Right? Substitute n equal to 0 in which equation I need to substitute? Either first or second. Substitute. Then what is K equation? Substitute 0 here, man. And what is K equation? And one more thing. What is stoichiometric coefficient I have taken here? 1. Means m I have to take it as 1 and n I have to take it as 0. Are you able to understand? Clear? Substitute m as 1 and n as 0. So what you got here? Minus 1 by t. Here. A minus x power minus 1. So this goes to numerator. A minus x. Here. So that goes to numerator. So a minus x minus a. A minus x minus a. Minus x. Already one minus is there. So x by t. So k equal to x by t. Response, sir. So I am writing next equation. K equal to a minus x by t. Correct? Respond, sir. A minus x by t, which is nothing but equal to x by t. Is nothing but equal to x by t. Why I wrote in this way? K equal to, instead of A can I write A naught, instead of A minus x can I write AT. So can I write as A naught minus AT upon T. Can I write like this? Can I write like this or not? Bring T to this side. AT to this side and KT to that side. So what you'll get? AT equal to minus KT plus A naught. Correct, sir? Say something. This is another equation. Now again, I am plotting one more graph. Here I am plotting graph between AT versus T. Now tell me, sir, how the graph is. Intercept is A naught, slope is negative. So graph must be like this. Correct, sir? So what is slope? Minus K. Intercept A naught. This is another equation. So we are seeing different equations, sir. This is one equation, means one type of graph between rate versus concentration. Second type of graph between concentration versus time. Third type of graph, sir. Third type of graph. At time t equal to t half, what happens to x value? A by 2. Correct? Correct, sir? If x is A by 2, substitute here, then what is k equal to? Or if x is A by 2, then what is k equal to? A by 2 t half. So t half equal to A by 2k. Correct? So t half is equal to A by 2k. That implies t half equal to A naught by 2k. Correct? Respond. Third type of graph we are plotting. Third graph is between t half versus A naught. Third type of graph between t half versus A naught graph. How the graph is, sir? T half versus A naught graph. What is intercept? 0. Slope 1 by 2k. Correct? Slope 1 upon 2k. Right? Correct, sir? So we are discussing about integration method in which zeroth order we are done. Why we are discussing this in this way? Observe. This is rate versus concentration. Zeroth order, first order, second order, third order. Means rate versus concentration graphs. One type of graph. Rate versus concentration. Second type of graph. Concentration versus time. Third type of graph. T half versus concentration. That's all. Three types of graph. So we have seen three types of graph for zeroth order or not? Rate versus concentration versus time, T half versus concentration. Same three types of graphs we will see for first order, for second order, for third order. Respond. We will discuss first order separately. Let me discuss second order, third order here. Why I am skipping first order here? First order equation is not this now. First order we will have to follow different equation. These equations we will follow in case of 0, second, third. Same. Correct? Now I am taking the side heading second order kinetics. Second order kinetics. What I will write, sir? Second order kinetics. A gives rise to products. You should say, sir, 2A gives rise to products now. But I am saying A gives rise to products follow second order kinetics. Means, so is it complex or elementary then? If I write 2A gives rise to products, now it becomes elementary. If I don't write 2 here, complex. Are you able to understand? Don't get confused, sir. I am writing now. I am taking it as elementary. Then what is molecularity? 2. Order 2. Right? Response, sir. The moment I write this, it becomes better. I will write. Now it became elementary reaction. Response, sir. If I don't write 2 here, then it becomes complex reaction. No confusion now. Now tell me, what is rate expression? R equal to K into concentration of AT power 2. Here I will write concentration of AT power 0. Here N equal to 2. Second order reaction, right? Response, sir. Graph. Graph, sir. Will get exponential curve or not? What happens to concentration of A with the time? Increases or decreases? As reaction is proceeding, what happens to AT value? Then what happens to rate value? Decreases. Rate is directly proportional to A. Na? If concentration of A is decreasing, rate also decreases. So to avoid confusion, let me write that in this way. Rate versus AT square graph. Now, rate versus AT square graph. Now straight line. Intercept 0. Slope K. Now substitute N equal to 2. Now I need to substitute M equal to 2. Elementary reaction. I need to substitute M equal to 2. N also 2. Correct? And say something. Be cautious. If I don't write this 2 there, then what I will do? I will write M equal to 1, but N equal to. Understood? Be cautious, right? If I write like this, now tell me the equation. Tell me the equation. K equal to 1 upon 2 minus 1. 1. 2t. 1 upon a minus x power 1 minus 1 upon a power 1. Answer. Any questions in it? Right? No confusion now. Now tell me k equal to 1 upon 2t into 1 upon a minus x minus 1 upon a. Respond. If m is equal to 1, better I will do one thing. Don't get confused, right? M is stoichiometric coefficient now. Yes or no? To avoid confusion, I am keeping that m as m, right? Or I will do one thing. Here I am writing 1 upon 2t. If m equal to 1, then what happens to the same k equation? 1 upon t into 1 upon at minus 1 upon a naught. Is there anything wrong? Correct or not? A minus x I am writing it as at, a I am writing it as a naught. Correct? Now bring that to this side. 1 upon at equal to 1 upon at equal to, bring this to this side. kt plus 1 upon a naught. Correct, sir? In above case, what you will get? Here, what you will get? 1 upon at is equal to 2kt plus 1 upon a naught. Or I will write mkt plus 1 upon a naught. Say something, sir. Yes or no? mkt plus 1 upon a naught. Correct? What I will write here? If it is zeroth order, emt. You will here also will get m or not? You will get mt. So k equal to, if stoichiometric coefficient m is not equal to 1, what I will write? K equal to x upon mt. K equal to a naught minus at upon mt. Kt equal to minus mkt plus a naught. Then slope equal to minus mk. Clear? Any questions? Don't get confused, sir. Clear or not? I will do one thing. I will delete this. I will write this here. Here also, I am writing that if m is equal to 1. No confusion, na? No confusion, right? Now again graph. I am plotting graph between 1 upon at versus t graph. How the graph is? Intercept. Slope. Positive or? Slope equal to mk, m equal to 1. That's why it is k. Intercept 1 upon a naught. No confusion, na, sir. General cases, it should be mk. That's why I'm writing everywhere if m equal to 1. Here also if m equal to 1. Clear? Be cautious, sir. If it is advanced, definitely they will not give m as 1. Mains, they will always give m as 1. Right? Don't get confused. If they give m is 2, n is 3. Accordingly, you need to write the equation, sir. Right? If I write m equal to 2, right? 2a gives rise to products follows third order kinetics. Then what I will write? 2A gives rise to products following third order kinetics. Then I will write M as 2, N as, so 3 minus 1, 2 into 2. Then it becomes 1 by 4T. Understood? Be cautious, right? Now coming to this one. What about at a time t equal to t half? At a t equal to t half, what happens to this equation, sir? Substitute t equal to t half. 2 power, what is that value? 2 minus 1, 1. So 2 power 1 is 2. 2 minus 1, 1. So total numerator became 1. A power 2 minus 1, 1. So A, M value 1. 2 minus 1, 1. K. So what is left? A, K. 1 by A, K. Correct? So T half equal to 1 by AK. That implies T half is equal to 1 upon A naught K. Again graph. What is that graph? T half versus 1 upon A naught graph. How the graph is? Intercept 0, slope positive. Slope 1 upon K. Right? In the same way, can you give for third order? Tell third order kinetics. Right? You complete it by next class. So in next class, I will not give this one. Right? Directly I will go for first order. So in next class, you try to draw all the graphs and respective equations. Okay, sir. I will stop the discussion. Right? Understood or not? Okay, online students, are you able to understand or not?
Yes, sir.
Anyone alive or not?
Understood.
Right, sir. Okay, sir. Bye, sir. Online students, you can leave. I will download your attendance and I will give it. Right? You can leave, sir.
Thank you, sir.
Bye, sir. Bye,
Thank
sir.
you, sir.
Yes, sir. Yes, sir. Bye. Bye.
Sir, RS present, sir.